Alrighty, hey organic chemistry. So this is another video where we're going to be talking about the nomenclature part 3, and we're going to start naming substituents. At the end of our previous class, we took some notes. Make sure you have the definition of substituent down, and I asked you to name the substituents that we circled. Just to remind you, these are all the substituents that we wrote down in class. So if you missed this, you could pause this video and copy this down. But this is how we name typically our carbon substituents. So if there's one carbon or like a line hanging off at the end, that's a carbon with 3 hydrogens and it's attached to whatever we're talking about. So something with one line at the end, we call that methyl. A couple of the examples in our notes have methyl. Right here, this is a methyl. In the third one line is a methyl. In this one, this example that I have, this I'll call a methyl. This is a methyl. And the very last one also has a methyl. So a line hanging out like that means methyl. If I have a folded kind of 2 lines, like 1, 2, that's CH2, CH3, we call that ethyl. 3 lines, 1, 2, 3, or 3 carbons, 1, 2, 3, this is N-propyl, but if it looks like the letter Y, that's how I like to recognize it, we call that isopropyl. If I have 1, 2, 3, 4 lines going out, we call that N-butyl. If it looks like a T, where I have 1 carbon with 3 carbons attached to it, all of them CH3s, we call that T-butyl. And so let's see if I could recognize this. This has 2 lines coming off at the end, so this is ethyl. You could just be checking your work. I know you did this yesterday, but I didn't specifically check with all of you. This is ethyl. But if we do it the other way, like Lexi mentioned in class, this is isopropyl. This one at the bottom here, this is ethyl. And then finally this bottom one, 1, 2, 3, 1, 2, 3, this is just N-propyl. Okay, now we're going to put all of this together with the beginning of our nomenclature rules. And you, of course, in this class, you don't have to memorize this, but here is what we have to do. You have to identify the longest chain or ring, number the chain and name it using the parent name. We've been doing that. Identify and circle the substituents. And then this is going to be the most important thing. Most important. Since that you've named and numbered, if there are more than one substituents, name them in alphabetical order. If there are multiple of the same substituents, use the Greek prefixes. They count towards alphabetical order. 2. I think that's a change in the rule. Just cross this out. The Greek prefixes do not count towards alphabetical order. So make sure you cross that out. That was a new updated change. So cross that out. The Greek prefixes do not count. And you'll see that later. So for example, right, I have to identify the longest chain, number, name the chain, identify and circle substituents. If I had something in a chain, the second carbon has an ethyl group, and the third and fourth carbons have methyl groups. The way that I would name this, if the second carbon has an ethyl group, I would say 2-ethyl, and the third and fourth carbons have methyl groups, 3,4-dimethyl. That's what I mean by if there are more than one substituents, name them in alphabetical order. I didn't do it yet. And then if there are multiple of the same substituents, use the Greek prefixes. So if I want to name this in order, I would name actually, ethyl comes before methyl. The di does not count in the alphabet. So it would be 2-ethyl, 3,4-dimethyl, and then whatever else is the parent name. I would name blank parent name. So this is just the beginning of us naming, right? You have to identify the longest chain, number the chain, and name it using the parent chain. Identify and circle the substituents, and then number and name the substituents. So if there are more than one substituent, name them in alphabetical order. Ethyl, methyl. The Greek prefixes do not count. If there are multiple of the same substituents, use the Greek prefixes. Greek prefixes do not count. Okay? So that is the beginning of IUPAC Nomenclature. All right, so you're going to have to know this word. You have to know what IUPAC means, the International Union of Pure and Applied Chemistry. All right, it's a world authority, and it tells us how we name all of our compounds. So there's standardized methods of measurement, atomic weights, and then other critically evaluated data. Okay? And so IUPAC, International Union of Pure and Applied Chemistry, is basically the law in chemistry. All chemists have to abide by the naming of IUPAC. So if I have a chemical and it's called something in one country, it better be called the same thing in another country because we have to be able to compare and look at that data. Okay? All right. So we may run into a numbering issue, and this came up with one of our examples before. How do I number the chain, and which way do I go? Okay, so if I want to number the chain, I could do bottom to top or top to bottom, right? So this was my longest chain, 1, 2, 3, 4, 5, 6, or the other way, 1, 2, 3, 4, 5, 6. And let me circle the substituent. Notice how it's on a different number now. This is going to be ethyl, ethyl. But they're both going to get different names. The longest chain is 6. So I'm going to write the parent name, which is hexane. And now combining what I mentioned on the page before, I'm going to use the number that I have the chain numbered with. You're going to have to number the chain backwards and forwards. So for this one, if I count it from bottom to top, this will be 4 ethyl hexane. If I number it from top to bottom here, this is going to be 3 ethyl hexane. So let's build on this rule 4, not just from yesterday. These notes are old, but not just from yesterday, but just from what I mentioned a couple minutes ago. Number and name are the substituents. Numbering. When deciding on numbering, like above, we want the lowest numbers possible. Lowest. Okay? For example, above, we got 3 ethyl versus 4 ethyl. The lowest number is 3. This is how I correctly name that compound. If we have multiple substituents, we may have to eyeball the lowest set of numbers or look at the numbers with the lowest sum. So for example, if I had like 1 methyl, 2 ethyl, 3 propyl versus 4 methyl, 5 ethyl, 6 propyl, like depending on where it was, I want to choose the lowest set of numbers. So that'd be 1 ethyl, 2 ethyl, 3 propyl. Like if these were two of the same compounds, like if it was like 1 methyl, 2 ethyl, 3 propyl, I don't know. Let's say it was like nonane. Or I had 4 methyl, 5 ethyl, 6 propyl, nonane. And I was trying to figure out which way to number it. I would go with the lowest set of numbers. Okay? Now that wasn't even, this is not even written the correct way because I would have to alphabetize it. So technically it would be 2 ethyl, 1 methyl, 3 propyl. But it doesn't matter. 1, 2, 3. 1, 2, and 3 is less than 4, 5, and 6, so I have to choose those numbers. And then alphabetical, and this is just old rule. Substituents are named in alphabetical order, not numerical order, and Greek prefixes do not count. We're not going to do that. Greek prefixes do not count in the alphabetical order. This has been an update and a change. And just to make this a bit simple for us. So we only care about the methyl, the ethyl, the propyl, right? That capitalization. All right? So if I had to do a quick example, okay, and I have a methyl here and a methyl here, okay, I could either number this 1, 2, 3, 4, 5. Actually, that's not going to work. Or I could do 1, 2, 3, 4, 5. No matter what, if I want to name this, I'm going to have a parent chain of pentane. No matter what, I'm going to get either 4 2,4-dimethyl-pentane, or 2,4, same thing. So no matter what, this is going to be 2,4-dimethyl-pentane, no matter what. But what if I had it, and I move the methyl groups a little bit over, what if I had it here? And I have 1, 2, 3, 4, 5. I can number it from left to right, or I can number it from right to left. 1, 2, 3, 4, 5. And now I have some options here. I could either name this 1, 2, 3, 4 dimethylpentane, or I'd have to name this 2, 3 dimethylpentane. Which of these would I choose that has my lowest sets of numbers? Well, if I just eyeball it, I know that 2, 3 is going to be lower than 3, 4. If not, 3 and 4 is 7, 2 and 3 is 5. I would name it 2, 3 dimethylpentane. So just to recap these rules, you have to look for and identify the longest chain. That's your parent name. Number the chain, and this is going to be important. I would number the chain 2 ways, and then you'll see that I have to find the lowest set of numbers. Identify and circle the substituents, and then number and name the substituents, and we just added to the numbering. When deciding on numbering like above, we want the lowest numbers possible. If we have multiple substituents, we may have to eyeball the lowest set of numbers. Okay? All right, so I'm going to do this first example for us. Okay? And make sure we cross out Greek prefixes do not count in the alphabetical order. So let's look at this one. Let me see if I could try and find the longest chain. So I know the rules may or may not have been a bit confusing, but once you do a bunch of practice problems and we do it kind of setting up with this template, we're going to be fine. All right, so let's do this first example. Let's see, I could do 1, 2, 3. No, that's definitely too short. 1, 2, 3, 4, 5, 6, meh. 1, 2, 3, 4, 5, 6, 7, maybe. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's going to be my longest chain. And I drew this structure on purpose. So I have my longest chain here. I'm going to number it 2 different ways. I'm going to do it with different colors so you can see it. Let's do left to right and then right to left. 1, 2, 3, 4, 5, 6, 7, 8. And then I'll do right to left. 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to circle our substituents that we had. So it looks like the ones that I didn't kind of put a part of my chain. Here's a substituent, here's a substituent, and here's a substituent. Okay? So now I kind of organized it a bit. And once you do a bunch of practice, this will be second nature. What is the parent chain? So for us, no matter what, the parent chain is 8 carbons. 8 carbons. We got all single bonds. That means it's an alkane. And to remind you, and we're going to go back a couple of pages, but if I want to name 8 carbons and it's an alkane, we did this on the earlier page. But if I have 8 carbons and an alkane, we got the name of octane. Remember, and I didn't do all of these, but you did practice number 2, where if I figure out the number of carbons, and I have on an earlier page, organic prefixes, 8 carbons in the chain, oct, and then if it's an alkane, it ends in ane, an alkene, it ends in ene, an alkyne, it ends in ine. So an alkane means I have all single bonds, oct means 8, so this is going to get octane. So that's the parent name, octane. That's a big part. Now we get to focus on the substituents. All right, so there are 3 substituents. All right, so how do we decide on the numbering of the chain? We want the lowest set of numbers. So what I like to do is, for the numbers, I talk about the numbers where the substituents show up. So if I do left to right, I got something on the 2nd, 4th, and 5th carbon. So 2, 4, and 5 versus, If I number it the other way, I got 1, 2, 3, 4, 5, and 7 versus 4, 5, and 7. Which of these am I going to choose? If you can't eyeball it, you could just add them up. 5 and 4 is 9, plus 2 is 11. 7 and 5 is 12, already higher, plus 4 is 16. So I choose 2, 4, and 5. So that's numbering it from left to right. And so now that I know I'm using 2, 4, and 5, what substituent is on the 2? So I got 2. 2 is, if it's one line, remember on page 15, one line means methyl. So this is going to be 2-methyl. On the 4th carbon, I have this T thing. Remember, on page 15, if it's T-shaped, we got T-butyl. So 4-T-butyl. And then on my 5th carbon, I have the Y shape. And remember, the Y shape is going to be isopropyl. So 5-isopropyl. Now, you put this in alphabetical order. We don't care about the numbers. I have M, I have T, and I have I. This is definitely going to be 5-isopropyl first, 5-isopropyl, then 2-methyl, and then 4-T-butyl. And then eventually I'll add in the octane. So if I want to put this whole name in, 5-isopropyl, 2-methyl, and then 4-T-butyl octane. Very ugly name, but very ugly compound. And so that was a guided practice on naming this massive compound. I want you to try and do guided example number 18 on your own, and we will check this in class. We'll do number 19 together in class, and we'll also do number 20 together in class before you do some practice. Alrighty, so hopefully this was a helpful video to help begin your naming. And then don't forget to cross out where it says use the Greek prefixes. They count as alphabetical order. The Greek prefixes do not count towards alphabetical order. So cross that out. It's an old, outdated rule. People used to use it all the time. Greek prefixes do not count towards alphabetical order. Okay? Alrighty. See you in a bit, organic chemistry.